Now we're going to have a look at the third and final method that you can use in order to be able to find the gradient. This is m, or in other words, the gradient is equal to tan theta, where theta is the angle that the line makes with the positive x-axis. Or in other words, the angle that you need to use is the one between the x-axis and the right-hand side of the line. In this case, theta is equal to 71.57 degrees, and you can see above that I've substituted this into the formula. And when you put tan of 71.57 into your calculator, you'll get an answer of 3. Now let's have a quick look at where this formula came from. You can see here a triangle with an angle of theta in the bottom left-hand corner. Labelling the triangle now, you get the adjacent side, which is one of the shorter sides touching the theta. You get the opposite side, which is the other of the shorter sides but does not touch the theta. And you get the hypotenuse, which is always the longest of the three sides and is always opposite the right angle. And if you think back to the trigonomic ratios, you get SOHCAHTOA, where sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Now if you have a look at our graph for a second, you actually can see a triangle which kind of resembles the one that you can see drawn below, where the opposite side, or also known as the rise from the x-axis, is equal to 8. Or the adjacent side to the angle, or also known as the run, is roughly equal to 2.666. So in this case, we can essentially say that tan theta is equal to rise over run, which is also the same formula for gradient.
That's right guys, I'm looking nice and brown, tanned if you will. Speaking of tan by the way, I'm now going to give you an angle that the line makes with the x-axis, and you're going to need to use that along with the function of tan to be able to find out the gradient of the line. So let's check it out.
Alright, so these questions say, find the gradient of the following lines. First of all, A, a line making an angle of 40 degrees to the positive x-axis, and B, the picture that you can see over here. Alright, so first of all, I've drawn out the picture here of what the line will look like. So you've got a line going up here, and it's saying it's making an angle of 40 degrees with the positive x-axis. Now this here, section here, is known as the positive x-axis because it's going up in the positive direction. Right? The negative x-axis would be going in the negative direction. Now it's saying 40 degrees with it. Well, that 40 degrees is in this section here, is all 40 degrees. Okay. Of course, if I kept going on, it still is 40 degrees because that little section here is 40. Now, I know that I'm talking about degrees, so therefore I'm going to use the third option, which is m is equal to tan theta. So I've got m equals tan theta written out as a formula here. Now I know that my theta is actually equal to 40 degrees, so it's m is equal to tan 40. And when I put that into the calculator, I get 0.839. So my working out for the second question looks like this. Now remember, when we're actually finding the gradient using a degrees, the degrees must be over on the positive x-axis. Alright, so at the moment it's on the negative x-axis. So what we want to do is make it to the positive x-axis, and of course if that there is 60 degrees, the whole lot is going to be 180. So what we're going to do is we're going to say 180 minus 60 is equal to 120 degrees. Therefore this section here is 120 degrees. So the angle that the line makes with the positive x-axis is 120 degrees. Alright, now because I'm talking degrees and I want to find the gradient, I'm going to use the tan theta. So m is equal to tan theta, which is equal to tan of 120 degrees, which is equal to negative 1.73. Alright, so now it's time to press pause once again and attempt the following questions. Remember that once you've finished them, press play and check them out against my solutions. Alright, so find the gradient of the following lines, a line making an angle of 30 degrees to the negative x-axis. So what I've done here first of all is I've actually drawn out the two axes, the x and the y, and then I've drawn out the line where it makes an angle with the negative x-axis of 30 degrees. Okay, so if I know that it's equal to 30 degrees, then this one here from around here to here, if all of it's 180, then this must of course be 180 minus 30, which is equal to 150. Alright, so I go through and I write my formula. M is equal to tan theta, or the gradient is equal to tan theta, and of course theta is equal to 150 degrees because the angle from the line to the positive x-axis is 150 degrees. So tan of 150 is equal to negative 0.577. Coming to this one here, it's a little bit more difficult. What we're actually going to do is we're going to move this 15 degrees up here because we know that we need to find out this angle here. So what I'm going to do is I'm actually going to make this line a little bit bigger by continuing it up like that. It's not perfect, but you can get the idea. I'm actually going to draw out, because if we keep this parallel line here like that to the y-axis, we know that this angle in here is 15 degrees. Alright, and I can figure out the rest of this angle from here to here because we know that is going to be 90 degrees. So of course the whole angle is equal to 15 plus 90, which is equal to 105 degrees. Alright, so therefore m is equal to tan theta, writing out the formula once again. Theta is 105 from the line to the positive x-axis, so tan of 105 is equal to negative 3.732. Of course the line is going down, so we know it's going to be negative, and it's pretty steep too, as you can see, which means that 3.732 would make sense. So summing up what we've just gone through in this lesson, you have got three methods to be able to find the gradient of a straight line. The first one being gradient is equal to rise over run. You use this formula when you get told the rise and the run, or when you have a graph that you can easily figure these two things out from. The second method is to use the formula m is equal to y2 minus y1 over x2 minus x1. And this is used when you get given the coordinates of 2 points that are somewhere along the line. The last of the three methods that you can use is m is equal to tan theta. And this is used when you get given an angle that the line makes with the positive x-axis.
Tell you what, I'm getting too old for this. Hey, hello guys! I just want to let you know that in all of my years of teaching maths, that I may have actually found a song that you young whippersnappers might like that might actually help you out with learning the maths that we've done today. So how about we check it out, hey? Let's go.
Rise up or run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. Rise up, run out. We mapping graphs to the triple R sound. We talking points and slopes, axes and origins, y-intercepts and quadrants, all four of them. The four quadrants start from the top and right, counterclockwise from the positive x and y. You go around, hit the 2 and then 3, bottom left negative. Remember that, please. You got a single point on the x-y grid. There's a single pair of values telling you where it is. This x coordinate goes from side to side. The y follows a comma to define the point's height. A straight line between 2 points is a relation. You can represent it with a linear equation. Y equals m times x plus b. If you wanna know the variables, listen to me. M is the slope, that's rise over run. It tells you how steep the line is gonna become. B is the intercept, that's how you assess the point at which the line goes through the y-axis. Rise up or run out.
A huge thank you guys for tuning into today's lesson, which is all about gradients. Now hopefully you now recognise that there is actually 3 ways to find the gradient, one being rise over run, 2 being 2 points, and the third being tan theta. Alright, it's extremely important that you remember that because the next lesson that you're going to be learning about is all about sketching graphs, and these skills are essential for being able to do that. Alright, so make sure you stay tuned for that very next lesson, and like always, say hi to your maths teacher for me. Aussie out.
Calculating that graph might be your best bet. On the X, you're measuring one day at a time, and your money gets tracked on the vertical Y.